Okay, the next things that we're going to be seeing is the central tendency measures. And like we talked about, is we don't always use the mean. We don't always use it. We sometimes, it's easier sometimes, probably the easiest one to be able to use that average, but we don't always use it. Why? Because the mean, and I have it here in Spanish, sorry, mean, median, and mode. Okay, why? Because the mean, for example, is very sensitive to extreme and insignificant data. It is very, very sensitive. Okay, so we want to be able to make sure that when we're looking at the central tendency at this middle number, to be able to make inferences that it's not, that our extreme data is not going to make it hypersensitive. Okay, the median is used when we have these extreme data. When we have, for example, grades, and it's between 70 and 80, and then all of a sudden we have a student who has a 10. That's a very extreme data that if we use the average, it is not going to be a true average, because that 10 is going to affect the average of all 80 students, maybe that have between 70 and 100, and just one student has a 10. But the median, what it does is, since we're choosing the middle number, it kind of eliminates those extreme data, and it helps us a lot. The mode is usually used, we can use it for all types of data. I mean, we can use it for ordinal, nominal, interval, and ratio, but usually when we use mode is we're using it for qualitative data, okay, when we can't use the mean and the mean or median. So you can always use the average. Okay, you can always use it. The mean is the average. You can always use it. There it is. Okay, you can always select all of these. And at the very bottom, you can see here, it's the mean. The median, there are other ways, and we'll see it. Median. There it is. And it's always looking for our data. There it is. Okay. And there's our mode. And it didn't select it. And there's the mode. The mode is the one that's most popular, the one that's used the most. There's another way that we can use it, which is easier sometimes to be able to use it. And we go to data, data analysis, and instead of using a histogram like we used in our frequency tables, we're going to use the descriptive statistics. And descriptive statistics is very simple. It's only asking for our input range, which is our data range. I'll select it. We're keeping columns because our data is organized in columns. Our output range is in F1 because that's the one we had used in class. And all I'm going to do is check mark the summary statistics. There it is. The mean, if you want to compare it, it's exactly the same. The median, exactly the same. And the mode, it's right there. It's a little bit faster when you use the data analysis, but it's always good for you guys to know that you can do it based on formulas. So let's look at a problem. We have two factory workers making car parts. The table shows how many complete parts each one makes in a week, okay? So we want to be able to see who is our best worker. So it says find the mean and the range. The range has to do with how far apart our data is. It's this number in particular. So let's go and just do our data analysis on this. Our descriptive statistics, just so we have it. This is for Rachel. Okay, our first worker is Rachel. And we'll put Rachel, I'm gonna put it right here. Okay. Oh, sorry. I did that wrong because our data is not organized in columns. Just trying to eliminate all this information. Okay. That'll format. I don't want to format. That happens sometimes, guys. Rows. It's organized in a row. Okay. So that's our data for that. Then we'll go here and do the same thing. It's in rows, but we don't want Rachel, we want John. Okay, we don't want it in O, we're going to want it in R. R2, there it is, R2, the summary of data, here it is. So we have the mean and the mean. We have the median and the median, and we have the mode. There is no mode here. He doesn't repeat data. Here you can see the 21 and 21 is the one that's repeating, and that's why she has it. So for the mean for Rachel and John, who is making more? Well, the mean actually tells us that the average of what Rachel, I'm going to go ahead and put Rachel here. Okay, so on average, John is actually making more parts. Okay, why? Because he has this 30, he has these 36. Okay, the range. So the range goes only two. There's only a difference between Monday, Tuesday, Wednesday, Thursday, and Friday of two numbers. +2, -2. I mean, she is very, very consistent in her work. And John, literally his range is 24. That means there's a huge difference between Thursday and Wednesday. Don't know what happens to Wednesday. Maybe he has a lot of meetings. Maybe he has another job, another position where it requires more attention on certain days. Whatever the case is, there's a big difference between Wednesday and Thursday. Or maybe he just talks a lot. You know, he talks a lot, and then he figures out, he says, oh, geez, you know, I didn't work a lot Tuesday and Wednesday. I better work a lot on Thursday to catch up. Okay, so there's the mean and there's the range. Who's more consistent? Well, Rachel is more consistent. I can actually say that Rachel is doing right now a more consistent job. She's more predictable. Who makes the most parts? Well, it's not Rachel. Here's the sum. Rachel makes 104 parts, and John makes 121. So who's more efficient? We'd have to have a little bit more information, probably more weeks to be able to measure it. But just in 1 week, John is being more effective. But the thing is that looking at this data, I would have to ask myself, what happened on Tuesdays and Wednesdays that makes him not even come close to, for example, his Friday output? So is it that he does have meetings or he's just goofing off? And maybe he would be a more effective player or a more effective employee if he would work every day consistently. Okay. So those are things that we need to be able to understand where we're trying to compare data. So we have here another one that it says a gardener buys 10 packets of seeds from 2 different companies. Each packet contains 20 seeds, and he records the number of plants which grow from each seed. You know, which one is actually yielding the most plants. So we'll do the same thing. We'll go here to data analysis, descriptive analysis. Instead of that input range, it is in rows, so we'll leave rows. Let's find company A. The output range, we want it down here because our information is down here. So we'll put it right here. And it's the summary of the statistics. And now we want data analysis again. Descriptive statistics. We'll change this input range because now we want company B. And the output range is what we'll change. We'll change it to S26. We'll leave the summary of statistics here. There it is. We have all of our data. And this is company A. Company B. Okay. It says find the mean, median, and mode for each company. Here's the mean. So just by the mean, we can probably see the company B has a lot more yield, or not a lot more, but more yield. The median, 20 and 17. Our data is a little bit dispersed. Okay. Our mode is 20 and 18, depending on our company. It says, which company does the mode suggest is the best? So if we're just using the mode, the most frequent or repeated number, we'd say company A because it is bigger than company B. Okay. Which mean which company does the mean suggest is the best? Well, the average suggests, or this mean suggests the company B is the best, okay? And then let's find the range for each company C. The range is 15 and 3. So finding this information, this range is much bigger, company A, because there are some packets that only yield 6 plants and some packets that are yielding 20 plants. Difference here, the range is only 3. So which one would you choose? Well, since we have these data 5 and 6 and 8, for example, these are extreme data because if I look at the 20s, it is actually telling me that that there are some packets that might be faulty. Something might have happened with the dirt, but they're not yielding so much, but they are extreme. So they are hitting my median or my mean, I'm sorry. But my median and my mode is 20. So if I was to come up and tell you which one I would prefer, I would probably tell you that I would prefer company A. It is more consistent. More packets give me the 20 seeds. More packets, I'm going 100% of a yield of what they're promising, okay? So this is one of those examples where I do have the mean is probably telling me that company B is the best. But if you see consistently, it is consistent because we're seeing that the range is 3, consistently, each packet is not yielding 100% of those seeds. It's not growing. It is growing a little bit less. None of these packets yield 100, which is also telling me something. There is always some faulty seed in all of companies B's packets. But there, even though I do have packets that have less, they are yielding basically very consistently, just some not as much, but they are yielding 100%.